Today's topic is power of lens. First, we will discuss the power of lens. Power of lens. Power of lens is a measure of the degree of convergence or divergence of the light rays falling on on a lens. Suppose I can give an example. Suppose this is the convex lens. Convex lens. Ray of light coming from here. There they're coming parallel. This is the optical center. Passing straight. This is the ray of light. Another ray of light. This this is called focal length. Yeah. We take another convex lens. Suppose this is convex lens. This is the optical center. Suppose here ray of light falling in. That means its focal length is this. That means smaller the focal length of a lens, more is the ability to bend light rays and greater it is power. Suppose this, when focal length is smaller, the lens is having more ability to bend the rays of light and greater it is the power. That means it is reciprocal. Large f, smaller the bending power. Large f, smaller the bending power. Small f, large the bending power. That means this power of lens is reciprocal of the focal length. When lens is having large focal length, it is having less. It is bending of ability is less, and when the focal length is smaller, the bending of ability is more. That means we can say large f, large focal length, smaller bending power. Number 2, smaller f, large bending power. That means if we write mathematically power of lens usually denoted by P, it is equal to 1 by F. It is a reciprocal of focal length. That means more is the bending, smaller is the focal. When the lens is having smaller focal length, more is the bending of power here. More is the bending of power. So power of lens is the measure of degree of conversion or divergence of light falling on it. That means it depends upon the focal length. When the focal length of a lens is smaller, the power of lens is more. The power of lens is more because large bending power takes place when his focal length is more. Here the smaller bending power, it is having a smaller bending power, from the diagram also. That this I have given the example of a convex. This is a convex lens. Both are the convex lens. But it may also be defined as, the power of lens is defined as the tangent of angle. The power of lens मैं आपको explain भी करूँगा. The power of a lens is defined, इसकी दूसरी definition is defined as the tangent of the angle by which it converges और diverge में होता है, फैलना होता है कि इसमें डाइवर्जिंग होता है, रे डाइवर्जिंग रोशनी कनकेव लेंस में diverges a beam of light falling at unit distance. This is important, at unit distance. Is unit distance from the optical center. I will explain you. From the optical center. First up, try to. The power of lens is defined as the tangent of the angle by which it converge or diverge a beam of light falling at unit distance from the optical center. What is that? If I take example here, suppose this is this again here, I can give it here, I can write here, suppose this is an convex lens, okay. You know this is an optical center, okay. Suppose this is the focal length of optical center, ray of light falling on it here, okay, falling on it, but when it falls it bends, the power of lens depends as the tangent of the angle by which it converges. It bends at some angle. When it bends at some angle, this actually the ray of light must be past straight line. This is the angle. Suppose this angle is theta. This angle is also theta here. That means the power of lens is defined as the tangent of the angle by which it converges. This is the angle by which it converges. Basically, this has to move in a straight line here, but it gets refracted here. That means it will refracted here. When it gets refracted here, it bends away from the normal. The bending, this is the bending angle. This, or we can say this is the angle by which it converges or diverges. This angle is called this. Because these two are, what are these? These alternate angles. These are alternate angles. That means tan theta, by which it converts or diverges. A beam of light falling at unit distance. This is the unit distance. This is the unit distance. This we consider it is a unit distance. Suppose this unit distance is h. H is height here. It is unit distance, actually unit distance. That means we can say tan theta by definition. The power of lens is defined as the tangent of the angle. This is the angle by which it diverges. This is the angle. This angle theta, because it has moved in a straight line, but it gets refracted here by a small angle. That angle is theta. That means by definition it is equal to the tangent of the angle by which it converges. It converges at an angle of theta. A beam of light falling at a unit distance. It is the unit distance from the optical center. Good. If I write in triangle, this tan theta is equal to perpendicular but a hypotenuse, that is equal to h bata this perpendicular but a base. This perpendicular but base is focal length here. But this height is the unit distance. Unit distance is 1. That is 1 by f. That means it can be also written as in terms of tan theta. Tan theta is equal to 1 by f. It is also the definition of a power of lens. That means power of lens can be also defined as the tangent of angle. It is a tangent of an angle by which it converges or diverges. A beam of light falling at unit distance from the optical center. That means it can be also written as tan theta is equal to, if we look in the diagram, tan theta is equal to perpendicular but a base, perpendicular is h, but h is here a unit distance. That means tan theta can be also written as 1 by f. That means we say, in short, we can say here is also power of lens is the reciprocal of the focal length. Here power of lens, from definition here, P is also equal to P. If you remember about definition, P is equal to 1 by f. That means it is also power of, in simple language we can say power of lens is the reciprocal of focal length. That means we can say power of lens is the reciprocal of focal length. I hope you have got it. Now I can go for SI unit. What are the units? Used to measure the power of lens? The SI unit of power of lens is diopter and is measured by D. That means the SI unit of power of lens is diopter. It is measured. It is by T. The SI unit of power of diopter. If focal length is equal to 1 meter, then power of lens is equal to 1 but focal length 1 by f. That is 1 by 1 meter. That means 1 by meter inverse. 1 meter inverse is called 1 diopter. इसी को हम diopter कहते हैं. DIOP TRE. 1 diopter is equal to D. That means it is the 1 diopter is power of lens whose reciprocal focal length is 1. That means 1 diopter is the power of lens whose principal whose principal focal length is 1 meter. And moreover, you should remember the focal length. Focal length of a converging lens is positive and that of diverging lens is negative. Therefore, power of converging lens is positive and that of diverging. We know that this is a converging lens. Convex lens is a converging lens. इसकी focal length इस side में है. Optical center के इस side में. That means we are moving in the direction of light. Its focal length is this side. अगर हम diverging lens की बात करेंगे, this is the diverging lens. इसकी focal length इस side में आती है. इस side में आती है. If you remember the previous diagram, इसकी focal length इस side में आती है. इस side में focal length. That means we can say the focal length of converging lens is positive. The focal length of converging lens is positive. That means its focal length is positive and that of diverging lens के क्या है? नेगेटिव. Diverging lens is negative. इसका मतलब है power of converging lens is, that means power of converging lens is positive. Power of converging lens is positive. Power of converging lens is power. इसका power क्या होगा? Negative. Power of converging lens is, this diverging lens is negative. Diverging lens is negative because it depends upon the focal length. अगर हम जो लेंस मेकर फार्मूला आपने डिराइव की, we can also write in terms of lens maker formula. We can, by using the lens maker formula, the power of lens can be expressed in terms of refractive index and a radius of curvature as follows. Because we know that 1 by f is equal to, if you remember the formula, mu minus 1 by r1 minus 1 by r2. Power of lens can be also written as in terms of like this, because we know that 1 by f is the power of lens. That means p is equal to mu minus 1 by r1 minus 1 by r2. This is all about, this is asked short type of questions, 2 or 3 marks question. You have to give a little bit definition of power of lens and you give it as a unit. I hope you have got it. Inshallah we meet in the next class. Thank you very much.